I saw lesson 13 changing the base, but we're not actually going to change the base because it's not really required for what we need to do. But there is some stuff in here that is useful that we're going to look at. So using our calculator. So I can calculate log base 10 of 3 squared in my calculator. It's going to look like that down there on the bottom. Actually, let's go ahead and look at log base 10 of 3 squared. Make sure that I put this out so that my parenthesis is on the outside. And it gives me an approximation. But what happens when I have, darn it, again, a different base, log base 3 of 3 squared, not log base 10 of 3 squared, but log base 3 of 3 squared. I can go ahead and go to my calculator, and I can hit math, and if I go down, it has a log base function. And there it is. So I'm going to use my log base function. And that allows me to change the base. So I can do log base 3 of 3 squared. Oh. Alright, and that makes sense, right? Okay, the next one that we have on this page is telling us to do log base 2 of 3 squared. So let's put that one in our calculator. We're again going to use our log base function, or you can go up and hit enter and it copies it down. And then you can go in here and change this. So you're allowed to just change that to a 2 and hit enter. Or you can use your log base function again by hitting math and going down or up, whatever gets you there faster. It's a log base. So then I would put a 2 and put my 3 squared. So that's a quick way to calculate logarithms if you have the correct calculator. All right, okay, moving right along. We are not going to justify these properties today. All right. We have just been introduced to something new. You notice that you have a log button and you have an ln button. They're both logarithms. It turns out that ln, remember I told you about Euler's number? This is where it's going to come in to use again. So natural log of x, what that is it's just a way of writing, it's a shorthand way of writing log base e of x, okay? Use a number. It's just a shorthand way of saying log with a base of e. We call that ln, which we say is, I will say, the terminology I will use to describe it is I'll call it natural log. Okay? So that's what I'm going to call ln, natural log. So hey, if natural log, and this is a total side trip that we're taking, but if natural log of, if it's log base e, right? Then shouldn't it be the case that log base e of e, what should that be? 1. It should be 1. Let's check it. So let's go to our calculator. I'm not going to use the log base because I can go copy it. And so I've got my E key. It's really hard to see on my screen. What I have is ln, right? Whoa! Slow down. We're just going to go e to the first power, right? And we'll make this that's no bueno. Let's get rid of this. Wow, I messed that all up. Here we go. It's because I had this 3 to the second, I need to delete it. I need to delete this first. It's very hard for me to see. There we go. So now I need to go in here and make this e to the first power, and then over here, you probably already got it because you didn't mess around with it as much as me. E to the first power, right? That's e. What did we get? Yes. Right? So it makes sense then, right? So then, likewise then, if I hit ln of e to the first, what should I get? Oops. That is correct. E to the first. All right, just kind of giving you an idea of what a natural log is, okay? It's log base e. All right. Which is also equal to. All right. We don't need to go through and punch these things into our calculator because you know how to push buttons. I don't want to insult your intelligence there. Let me show you how to push a button. Push the LN. Push the button. We're good. Okay. We are able to make a conjecture about this, about comparing log base 10 and log base e, but that's not necessary for us. Okay. This, however, we do need to do. Here we go. We're going to apply our properties of logarithms again. So we're going to get a little more, a couple more examples, but now we're using natural logs. Same as log base 10. We're going to use the same operations as we would with log base 10. All right? So, for instance, remember, if I was going to write this as a single logarithm, first thing I need to do is take any coefficients on the outside and bring them in, right? So this is going to be minus natural log of 1/3 to the 3 power, right? Just brought that in, plus natural log of 2. I'll go ahead and write this as natural log of 4. I'm going to simplify this 3. I'm going to raise everything in my parentheses to the 3rd power. So this is going to be the minus sign on the equal sign. Minus natural log of 1/9 plus natural log of 2. Now let's put it all together. I like to do my subtraction first. So I'm going to write that as a quotient, right? So that's natural log of 4 over 1/9. Because when I subtract, right, I can take this 2 and I make a quotient. It's just weirder because I have a fraction of it, right? Plus natural log of 2. So 4 divided by 1/9, you can put that in your calculator. It will go ahead and spit out for you 36. Right, I'm just flipping and multiplying. I take the 1/9 and I multiply it, I flip it, it becomes 9 over 1, I multiply it times 4, and I get 36 over 1, right, which is the same thing as 36. And this is natural log of 2. And then for my last step, I put them together, and when I put them together, I multiply, right? 36 times 2 is going to be 72. And there we go. We wrote it as a single logarithm. We're going to get lots of practice with this today. I have some exercises ready for us to get a little extra practice with the properties of logarithms. All right, so yeah. Sorry, we keep that last step up there for you. Okay, so the first thing I'm going to need to do is bring exponents inside. So this 3/5 is now going to come inside, and that's going to be natural log of 32 to the 3/5 power minus natural log of 4. Okay? So that will be natural log of 5. I'm going to go ahead and write this as a radical. Yeah. So this is going to be the 5th root of 32 cubed. Minus natural log of 4. Okay. I have a tendency, it doesn't change it, but I have a tendency to like to deal with my subtraction first. I like to make a quotient first. So this is going to be natural log of, right? Since I have this one minus this one, right? This stuff is going to go in my numerator. This is going to go in my denominator. So I'm going to have natural log of the 5th root. Sorry, read that. But I put these lines in the way of my multiplying here. So natural log of the 5th root of 32, working for me, 32 cubed over 4, right? I said this is my numerator and this one is my denominator. Now I'm going to write it as a product, right? So now this should be natural log of 5 times the 5th root of 32 cubed over 4. I'm just multiplying. What do? It's like I'm multiplying 5 over 1, right? Times this quotient over here. If I do that, there's really nothing I can do but write that coefficient of 5 out there. So it's 5 times the 5th root of 32 cubed over 4 here. Huh? Pretty much multiplied, right? That's 5 over 1. Yeah, there's no, I can't like multiply it out. If I did, I could, but I would get a decimal. Most likely, I don't know. Let's see. Is it the case? Does the 5th root of 32, dang it, pull backwards writing there, 32 cubed, does it have a whole number answer? Let's see. So if you don't have a calculator that does the roots, you can just write that as 32 to the, oops, I keep hitting the wrong button. Can't really see very well. To the 3/5 power, right? Isn't that what we had it written as? Over here, 3/5 right there. Right, 3/5 power. Oh. Okay. And what do we get? Ooh, it's actually 18. All right. Okay. 8. Sorry, there's a little smudge there. There's a little glare, and it looked like there was a 1 there from my perspective. So, all right. So we can simplify this further. Because we've determined that this right here, that's 8, right? So then this becomes natural log of 5 times 8. Would have been easier if I would have done that in the first place, right? Would have been less writing. 5 times 8, 40 over 4, which becomes natural log of 10. That's a much nicer answer. I like that much more. All right, let's go ahead and write each expression as a sum or difference of constants and logarithms in simple terms. All right, so in other words, we've been condensing. Now let's go ahead and expand it. All right, here we go. The first thing I'm going to do is I'm going to break this up, this quotient up. Square root of 5x to the third minus, right? Natural log of e squared. Ooh, I see something right away, right? E to what power is e squared? 2. So then this is just 2, right? Natural log of e squared is 2. Well, that's easy to take care of. Let's take care of that right away. Now this one's a little nastier over here. Natural log of, I'm going to go ahead and write it as 5x cubed to the 1/2 power, right? So the square root is the same thing as raising something to the 1/2 power. And we just determined that this stuff is 2. Yay! Now let's go ahead and take this 1/2 and bring it out the front. So I have 1/2 natural log 5x cubed minus 2. It's getting better. So now I have to break these two things up, right? This has 5 times x cubed, which means that I can write this as a sum of 2 different logarithms. So I'm going to go ahead and do that over here. I'm going to start a new line. And so that's going to be 1/2 times natural log of, I'm going to not write that for you, sorry. 1/2 natural log of 5 times, or plus rather, sorry. Remember the 1/2 has to go with both of them, right? If I have a coefficient out front and I'm separating something inside my logarithm, that coefficient has to go with both of the things, right? Both when I'm separating. I just say that a lot because it really is the most common mistake that gets made when we're doing this. One more step, last step, is to take this 1/3 and multiply it times the 1/2. It's going to come out to the front. When it comes out to the front, like I said, we're going to be doing multiplication. I'm loving that lighting right now. Okay. And there it is. It's done. How do I know when I'm done expanding these? How do I know? I know when every single one of my terms that's inside of my logarithms is just one term. It's not multiplied by anything. It's not raised to any power. I just have one thing in there, okay? When I just have one thing in there, I know that I'm done. Time to move on to the next problem. All right? Which is what I'm about to do. Okay, what? Yeah, that's right. Oh, really? Here we go. Again, I have a quotient. Hooray for that. Oh well, let's go for it. So I'm going to write it as, so this is x plus y squared minus natural log of x squared plus y squared. Well, thank God there aren't minus signs there, because otherwise I would have to use difference of squares. And I don't want to. Alright, so it looks like I can take this 2 and bring it out to the front. So this is going to become 2 natural log of x plus y. And this is going to be just, I mean, there's nothing I can do with this. I don't have a rule yet that says what I do when I have a sum within my log, right? You only have a rule for multiplication. So then this is just going to say natural log of x squared plus y squared. That one was easier than the previous one. It just looked more complicated, right? Be careful. I can only apply these properties to the logarithms when I'm taking the log of a product or the log of a quotient, right? If I'm dividing or if I'm multiplying. Otherwise, if I have log of x plus y, I can't really do anything with that, right? Yes?
How are we supposed to have the numbers completely broken down? Why is it okay to have x squared plus y squared?
There's not a product in there. Right? There's no division. I can't do any division. I know, I just said when are you done when there's only one term in there. And then we get this wrong. There's no multiplication, there's no division. And by no multiplication or no division, I'm also talking about exponents as well. Because those are just special cases of multiplication. Yeah? Did I just finish? I did! Yeah? Fantastic.